We are here today at the Westhafen, which belongs to the Behala, so the main port in Berlin. It's part of an initiative which we call a digital testbed on the Spree-Oder-Waterway. And the main idea is to get more transport back on inland waterways, especially here in Berlin. The vision of this initiative was to enable an eco-friendly transport on the inland waterway by using smaller vessels which are then autonomously driven and could be used for silly logistics. We were developing a kind of sensor network using automotive radar sensors. And this is because we currently have on inland vessels the main navigation radar sensor, which is good for all the distance behind 100 meters, but it's almost blind for all the distance in between or closer to the vessel. And therefore currently mainly optical sensors, these are cameras and lidars are currently being used. But those sensors have the issue that they are not working as good on bad weather conditions. And therefore we had the idea, okay, why not use those sensors which are well established in other fields of transportation and cars? Consortia built of the manufacturer of the sensors. Then we have the BTU, which are experts in signal processing for really adapting the sensors to the application on inland waterways. And we have us as DLR, which already have some background knowledge on the application on inland vessels.
InnoSent is a leading company for radar technology. We are developing and manufacturing radar sensors and radar systems for automotive and industrial applications. The aim of the project was to find out if we can use the relatively cheap radar technology in the automotive application. And we want to close this gap from close distance, starting at a few centimeters, up to 100 meters or 200 meters. This is what usually automotive radars do. These radars are modified for the ship application. We transmit an electromagnetic wave. We have a certain footprint, we call it modulation, and the wave is transmitted, is reflected by an object and gets back to the radar. We can measure distance, we can measure speed of the object, and we can also measure the angle of arrival of the electromagnetic wave. The biggest challenge in the project was to adapt the automotive sensors to the application on the boat. It was necessary to invent and develop new antenna topologies, new modulation schemes, and also the signal processing needs to be reinvented, let's say.
So we are focusing on the radar processing and transforming radar data into something what I would say humans or machines can process involves a lot of sophisticated signal processing, because radar data is not like a camera or a lidar where you get a picture or a 3D point cloud, but first of all you receive echoes from the environment, and out of those echoes you kind of have to create those pictures from the environment, and this exactly is our task. So there's a couple of challenges involved in this project. Of course, radar signal processing has been researched for decades, and radar signal processing algorithms are well known, especially from the automotive domain, right? We all have radars in our cars today. They basically never have been researched really for this application, and the environment and the scenario here for this inland shipping is quite different. So we have very reflecting water surface, or if you exit a lock, then you have parts where you have open waters, which means we kind of have really to adapt the signal processing to always get the optimum performance. And this is quite very challenging. In addition, also, the degrees of freedom of the ship are much larger than a car, right? A car typically is flat on the street, the ship moves in every direction, and this of course also impacts the radar data which we receive and which we have to process. There had been many groups researching autonomous vessel operations before. those experimental systems were based on LiDAR sensors because they are much more intuitive. However, you can think about if there is bad weather conditions, then typically LiDAR has great challenges, and this is the benefit of radar. However, the resolution of a point cloud, which means the spatial resolution, how many points we get per cubic centimeter of radar, is naturally much lesser than you get from LiDAR. And especially this comparison is very interesting for us, because the question is, do we see everything what is of interest with the radar, or do we miss some objects or obstacles which might be there? And basically the project showed us that with radar we can really detect the most important features of the environment, and there's also a couple of objects like ducks, for instance, in the river, which radar can detect much more reliably than, for example, a LiDAR sensor.
So our part is to interpret the sensory data from radar and also our sensory data pipelines that we already developed for inland waterway applications, and to compare these two solutions and see the feasibility of radar data into the regard of the inland waterway domain. So since we're in an open air scenario, we can assume the localization and the navigation positioning of the vehicle we are targeting to localize is solved. So we get signals from the GNSS, so from the satellites, and then we are able to position ourselves with a sub-centimeter accuracy. And then with this localization solution, we are able to get the point cloud data coming from the perception sensors, as it can be radar or LiDAR. And then we stitch together these point clouds over time in the frames that we know the localization, and we start building this map around and mapping the environment. So real-time processing is considered in these terms when it happens within a time scan. So for instance, when we talk about LiDAR, we are saying that we get every 0.1 second one scan. And then we can say that if we manage to solve the mapping, so we manage to update this concurrent update of the different point clouds within this scan, then we're talking real time, and we can achieve this real time. So basically, once you get the map, you are able to extract different features from what you see around you. So at the end, one of the end goals is to pursue automation in different maneuvers. But automation doesn't mean to move by yourself, which might be the most known level of automation. You can also go some step backs and solve different solutions, which might get you closer to get different automated maneuvers. For instance, might be vessel detection in terms of inland waterway scenarios, or also quay wall detection, also bridge detection, which is also key for avoiding collisions, for instance. And definitely on the LiDAR side, we get a way denser point cloud than the one we get from the radar. But the main advantage from the radar is you get a estimation of the velocity per point, which might be super beneficial. Some navigation pipelines when you are using only these perception sensors, which is extremely useful. Might be also useful for target detection. So when you use radar and you have the velocity of the point you are perceiving with the sensor, you are able to say, okay, this is a moving object, and by the shape you can then say, yeah, this is a vessel. Or by the other side, it could be also a wall.
My name is Martin Sandler. I'm the CEO of the company Argonav. We are located in Stuttgart, and we are the leading German manufacturer for inland access systems for vessels. This means chart systems that provide information on a central location in the wheelhouse to the skipper. We are very interested in new sensor technologies, enabling us to provide new assistance functions to the skippers and to shipping, providing more information and in the end also, of course, more automation of vessels.
Now we have this massive amount of data, and of course we have many ways to optimize the signal processing, so to improve the resolution, to optimize the waveforms which are used for sensing the environment. So this is what we are interested in from the research side. And then of course the question is, what else do we have to do to really bring it into application? Because at the end, the goal of course is to enable really autonomous ships on our waterways with this project.